Hi, I'm Matt Lewis. I'm an assistant professor in the design department at The Ohio State University. While my education was in computer science engineering, I've spent most of my career working at the Advanced Computing Center for the Arts and Design, or ACAD, an interdisciplinary computer graphics research center. I'm also core faculty in our university's Translational Data Analytics Institute. I've been collaborating on emerging technology projects across many disciplines for the last few decades. I'm going to talk about my recent work capturing familiar spaces and shifting them to new physical locations. Virtual reality typically completely obscures your physical space, while augmented reality usually integrates objects into your current environment. But weaving a virtual space through a physical location creates a context-dependent liminal space experienced somewhere between these two realities. I originally wrote layering, but recently one of our grad students has me contemplating weaving, which might be a more appropriate metaphor. A few of the examples I'll discuss include workplace research environments brought home, students bringing part of their home to school, and reconstructions of silent film architecture. I'm first going to talk briefly about creating virtual versions of familiar physical spaces. I'll then discuss how we've been relocating them with AR. I'll show and discuss a few examples, and then I'll end with some thoughts on implications and next steps. Before the pandemic started, a grad student named Joe Chambers and I were working with 360-degree panoramic photos and started looking into software for transforming these into virtual environments for use in VR. We found the available software a bit too challenging to work with, but it turned out that this sort of mapping process was well established historically in computer graphics research, but it had been mostly impractical in the past. Recent technologies were on the cusp of making it potentially useful, so I began developing a process that I and my students might be able to use that would let us build photoreal environments of familiar places for use in our VR research. Some example virtual environments are shown here. Once I had sufficiently documented this process, I was able to hire a graduate MFA design student to work with me on research projects that could make use of this new capability. Emily Suber was hired to work on a project that involved creating a virtual version of a research preschool room. We had hoped to try out different possibilities for connected speakers and lights without having to use the very busy physical space for our prototyping. We not only needed to capture and create the virtual space, but then also be able to experience it in VR using virtual technologies. After the pandemic started, this project study was put on hold. The idea of enabling people to virtually visit remote spaces took on extra significance during the early pandemic as buildings were closed, work from home began, and unnecessary physical visits were discouraged. Emily and I, along with grad student Catherine Chu, have since prototyped several experiences combining real and virtual spaces using virtual technologies primarily for prototyping data visualizations using XR. Shown here are virtual monitors, projections, smartphones, and interactive AR concepts in both virtual and physical spaces. This work was primarily funded by the Translational Data Analytics Institute, whose building spaces you're mostly seeing here. Here's an example of what I mean when I refer to virtual prototyping using XR and simulated technologies. If you have even a simple photo-based 3D environment of a space, then you can put that space in VR and then use virtual versions of technologies like a virtual smartphone running a virtual AR app. And then you can try out different AR concepts remotely in VR instead of always needing to actually be physically on site in the real space. You saw here Emily looking at a virtual grid of digital humanities images that she'd queried using AR, and in this case these were images of popular international female singers. Traditionally, augmented reality is primarily used for placing individual virtual objects in physical spaces. An example is this virtual tree project done last year with my graduate student Juan and Steve Lyon, a professor in our School of Environment and Natural Resources. The project's goal was to visualize tree planting possibilities and environmental sensor data. It's all well and good to discuss and imagine a large tree in someone's front yard, but seeing and feeling its size and impact on your view can be really impactful. but this of course requires that you actually travel to the physical location of the proposed tree. Augmented reality head-mounted displays could someday radically change this area. They can greatly impact immersion and presence over holding up a phone or tablet with your arm, but like Apple and Google in recent years, we've been mostly focused on common handheld mobile devices for our research instead of expensive head-mounted displays like Microsoft's HoloLens or Magic Leaps, even though we do have a few of these around. Newer, less expensive wearable displays are expected in the next few months, like the Lynx shown upper right, that cost a quarter of the price, but these sort of things are unlikely to be common for at least a couple more years. We've remained focused on smartphones and tablets for AR display mostly because of how readily available they are for students to work with. So AR is great for placing virtual objects. If, for example, I want to experience what some generative art plotter drawings hanging in the hallway outside my office might feel like, with different arrangements and sizes, then AR is indeed ideal. Because I've created a virtual 3D version of my hallway, I can do this in VR if I like, and I can also then walk through the walls, which I definitely can't do at work, but it also means that I can open this space as an AR object at full scale and place it wherever I like. I can then walk around inside and outside of it in some completely different context. Here I've quite literally brought my work home with me and feel like I'm walking around at work while I'm actually in my backyard under our willow tree. My body feels all the stress and formality of the office, but layered with the comfort of the summer sun on my face, our garden behind me, and the sound of the wind. This ability to place 3D spaces as AR objects has recently enabled students in my design studio class to start prototyping technology system concepts in real spaces, but also to bring those spaces to school with them. This past year, one team of design students was interested in surveillance and sleepwalking and made some really thought-provoking work. One of them used smartphone 3D scanning at home to create a model of their room. They then placed this virtual room data as an AR object in a large lobby space at school. This allowed them to choreograph and film themselves walking around in the virtual space to communicate and prototype their design ideas without having to actually all travel to someone's house. This work was done by Ashlyn Damron, Sierra Dayan, and Josh Leidick. But what about experiencing previously real spaces that we can no longer visit? I was recently working with some film history faculty and students at Dartmouth who are researching early American silent films that are being restored from paper prints. This clip is showing one frame of the storefront from the 1909 film The Chord of Life, and it's been made into a 3D environment that you can walk into while looking through your smartphone or tablet. And while I recorded this video in our simulation lab space, it can just as easily be located and explored anywhere that you could bring your phone. It turns out that the block in Fort Lee, New Jersey, where this silent film was shot, was used for shooting many silent films around 1910. Shown here are some frames from other films that show neighboring buildings from different angles. 3 of these images were provided by Dennis Doros and one from Mark Williams, both via Tracy Gossel and the Biograph Project, which has been restoring films like these. And I should mention that this silent film AR work that I'm discussing was part of the Media Ecology Project, a digital humanities research initiative directed by Mark Williams and John Bell at Dartmouth College in relation to the NEH Digital Humanities Advancement Grant, Understanding Visual Culture through Silent Film Collections. So those buildings can be extracted from these film frames and then roughly arranged and remapped to recreate this historic street virtually. I'm showing here my favorite 3D software called Houdini, but nearly all 3D animation software has the capabilities needed to project images onto 3D surfaces through what's called texture mapping. Using photographs in this way is less common, and it's made particularly tricky when you don't know much about the original physical film camera that shot these images. I'm making tons of assumptions and guesses about the historical truth, since I don't know things like the camera distance and height or lens properties for the 7 camera shots I'm using here. Once virtually recreated, though, This block of storefronts can be placed anywhere, like a hologram that can be seen by looking through your smartphone screen, like a window into the past. Last summer, I happened to be traveling when I finished assembling this model, and I walked outside the place I was staying, along the river in downtown Missoula, Montana, and placed this old city block in the park, and then spent a long time experiencing a taste of what standing in front of these buildings at this scale 100 years ago might have felt like. Obviously, the buildings were not black and white or mostly flat and so on, but the sense of virtual place is something you can notice in your body, feeling the size and proximity. But you also feel the physical environment around you at the same time. The tree, bridge overpass, and sculpture also felt present in the space. We're in a unique moment before AR glasses arrive, where using our phones as our AR displays is not as technically immersive, but our attention is disproportionately on our phone despite the relatively small field of view of the screen in our hand. Think of the very problematic attention blindness of a person reading texts while walking across the street, or worse yet, driving. This is in some ways the inverse of the early AR HMDs like the HoloLens, in which the edges of the small field of view annoyingly distract us away from the virtual content. Our eyes lock on the phone and mostly ignore the surrounding world, but all our peripheral vision is fed to our body despite our attention being elsewhere, a bit like when you drive on automatic pilot with your thoughts focused on some conversation you recently had. I want to say something about mind-body metacognition here, but honestly, I just mean noticing that we're thinking almost entirely about one thing, while we also feel the presence of what's around us as we avoid walking into a table or the tree next to us. Where it gets really interesting is when we end up treating virtual objects as if they're physical, walking around them automatically or even trying to lean against them without thinking. Performers, inspectors, and designers, of course, often do require physical interaction as part of their work. I occasionally travel significant distances to physically interact with others in specific spaces, as seen here, where I've just been thrown on the floor of this particular Aikido dojo. It'll be extremely challenging to relocate and sufficiently replicate many site-specific physical experiences virtually for a very long time. However, climate change and related sustainability challenges are pushing us to reduce our unnecessary travel as much as possible, obviously. But back to virtual spaces. There's a few easy ways to share virtual environments for use in AR or VR. If the environment is not terribly interactive and has limited animation, one can simply link it from a web page just by copying the geometry file to a web server and cutting and pasting a little HTML. Free JavaScript libraries can handle the AR portion, while a free website, such as Glitch, will let you put your web pages online so you can simply share a URL or QR code to share the virtual environment. The couple dozen lines of HTML you see here are mostly just cut and pasted to say, allow this 3D model to be displayed using augmented reality. My students have been able to learn this part very quickly. Learning to work with 3D modeling and texturing software, of course, takes a bit longer. I've tried to mostly avoid commercial software with restrictive licenses that require app installation and app store review processes before you can share your virtual environments. Free open source web-based software seems to provide easier access and sharing for our students and researchers. Some of the web software we've been using includes the libraries I've listed here, but all are free and just require that you have a web browser. Again, the major advantage of using web technology is that you can just click a link, type a URL, or scan a QR code to see these experiences. When I was first remotely showing that street model at a film history conference this year, I shared the web address in my slide from Zoom, and one of the on-site attendees was easily able to reposition and shrink the model of the street onto the table in front of them within the auditorium. But let's talk briefly about the subjectivity of memories of spaces that no longer exist. Years ago, when they were going to renovate the building I currently work in, there was a very old, dark marble rotunda This World War I memorial was going to be dismantled, and I was curious about LiDAR data and knew a guy with a scanner, so we scanned the space and shot a panoramic photo. At that time, we envisioned enabling anyone after the renovation to see this historic space where it used to be, as shown in this mock-up. 360-degree photography was just emerging and provided one curious low-tech solution before AR tracking became more commonplace. It turns out that if you ask a viewer to stand in a known location in which you've taken a 360 photo, then you can simply align and overlay your 3D model with that new 360 photo and simply share the resulting augmented photosphere via a web page, perhaps with some transparency as I'm showing here. The curious result, however, is the role of familiarity. My brain is able to fill in the gaps, interpolating between the two spaces, because of all the time I had spent in that former rotunda. But this new hybrid environment will be experienced very differently by those who were or were not ever in the original space. This activity of remixing spaces like this is interesting to consider. New platforms for creating and sharing media tend to lead to new remix cultures. The explosion of TikTok and other short video social media created a generation with very impressive video editing skills. And last year, when crypto suddenly spawned a robust NFT market, mostly obscure generative computer graphics drawing techniques were suddenly rediscovered by a large new community who began remixing and sharing them online. Technologies such as 3D generative AI, Apple's growing support for AR and 3D capture, Google's computational photography research, and the eventual support for actual high-speed 5G and even 6G in a few more years, all may provide the fuel to spark a revolution in using 3D spaces as media content to locate, layer, share, and experience. Generative AI is a particularly interesting case in any discussion of remixing contexts. Anytime we gain this ability to manually remix and share some new media type, programmers then have always created generators that procedurally remix surprising combinations. But this pattern these days now leads to machine learning. AI can be given examples as data, which it then uses to learn more generic attributes of these spaces. This then creates a latent space that can be explored via interfaces, such as descriptive text prompts or simple sketches. Shown here are some images I generated from text prompts, but full 3D environment generation from descriptions is just around the corner. What are the implications as we continue advancing week by week towards asking AI to show us more ideas in these spaces than we can possibly navigate interactively? There are also, as always, very significant questions about the boundaries and biases lurking in these processes, and it's difficult to understand the limitations. Some of the diverse spaces that I'm working on or starting discussions about include capturing outdoor neighborhood streets for some healthcare research, experiencing medieval spaces as portrayed in very old books, an arboretum as a particularly challenging space for AR prototyping. I'm hoping to visualize the complex landscape of wireless signals in outdoor spaces, and I just started a great discussion with a colleague about theater set design possibilities. It's really great to work at a great interdisciplinary community, and I highly recommend it if you get the opportunity. Most of the web-based augmented reality work I discussed is available from my website, and you can use the URL shown here. I'm looking forward to discussing these AR space explorations further with anyone interested. So please feel free to contact me with your feedback or questions. And thank you for listening.